Okay, this video is for Math 1, Lesson 1.1.2. Okay. And again, we are looking at building expressions and identifying the different pieces of the expression. And now what we're focused on in this lesson is if we change a piece of an expression, how does it affect the other pieces and the overall expression? So again, all these things is, can we take a situation, translate it to math, and understand the different components? Let's take a look at the first example. Okay, if you buy a car, it loses an average. So I'm going to highlight a couple of key words here. It loses an average of $1,800 per year. Okay, so buying cars, definitely losing money for each of the first 6 years of the ownership. Okay. When Mina bought the new car, she paid $25,000. Okay. So therefore, we're able to come up with the expression 25,000 minus 1,800y. Okay. So let's first talk about what those pieces are. So let's kind of bring the equation down here. We have 25,000 minus 1,800y. Okay. Now, first identify what's y. Y is the number of years. Okay. Now again, this is for, if y is less than 6 years, okay? Because, it could change after that, and it does, okay? So y is the variable, okay? So let's identify the pieces. And that is a piece that changes. Then we have 1,800. That is the coefficient. And that tells you the number per year, okay? So it's 1,800 for the first year, another 1,800 for the second year, and on we go. So we call that, a rate in this case, okay, like a rate of change. Then this is the constant. And why we identify as a constant? Well, mathematically, it's a number all by itself. But notice the price of the car does not change. So let's kind of take a look at the scenario, what they want us to look at. Where y represents the number of years since Nina bought it. What effect, if any, does the change in the number of years since Nina bought the car have on the original price? Now, let's think about the scenario. If Nina walked in and said, I'm going to only own this car for 2 years, the sales guy is going to tell him $25,000. Now, if Nina walks in the next day and says, well, I'm going to own this car for 6 years, the salesperson is still going to say the car is still $25,000. The price of the car does not change. So I'm going to make a note of that here. Or what does change? This change. Now notice these are two separate terms. We have the original price of the car minus the loss. Okay, so maybe I could write that as an expression here. So we have the car price minus how much you lose. Now, notice the 1,800 doesn't change. It still loses the same amount per year. But the one thing that changes is the y. Okay, and that's why it's a variable. Now, if the y changes, the whole term changes. So if it was 1 year, it would be $1,800. If it was 2 years, it would be $3,600, and on we go. So this whole term changes, but it changes based on the change in y. 1,800 doesn't change as a coefficient, and definitely not the price. So again, what we're doing is identifying the pieces and what they mean, and as things change in the expression, what changes overall. Now, does the overall price of the car change year after year? Yes. The whole expression changes, but again, it's all based on the change in y. Let's take a look at our example. Okay, so here it says to calculate the perimeter of a isosceles triangle. Okay, the expression 2s plus b is used. So anytime we have a situation like this, it's great to draw a picture. So I'm going to draw a picture of a isosceles triangle. Isosceles triangle means that the two sides are the same length. Okay, so this expression, I'm interpreting that this is called side s, that's called side s. They're both s's because they're the same length. Or this is the base, so we call that b. Now, notice I use different letters because they're different variables and they mean different lengths. If this s changes, this one changes with it. So if this is 6, that's 6. If it changes to 8 and 8, then so be it. The base is independent. So we have the expression 2s plus b. Okay, so let's take a look at what it wants us to take a look at. What effect, if any, does increasing the length of the congruent sides? So let's say the S gets bigger. So I'm going to draw another picture of it right next to it. The B is the exact same. Okay, so I'm going to just make a note here. It's the same. Let's say the S's got longer. So the thing got taller here. And it's a new length. Okay. And that's the other thing about variable. The variable can change. So this is like a new S. And they get bigger. What effect does it have on the expression? Now notice, this is a term and this is a term. Okay. This has one factor in it, which is a variable. This has two factors in it, a coefficient and a variable. So how does the effect change? Well, will it change the overall expression? Yes, it will change. Yes, changed here. Okay. Does it change the effect of the B? No. The B stays the same. Okay. Does it change this term, the overall length of the S's? Yes, it does. Okay. So a lot of times students get confused here and they're like, well, yes, it changes because they're thinking of the answer, a lot of students want to call it. But we have to think what actually changes. The sides change, the 2 doesn't change, the number of sides in the triangle doesn't change. This, the S changes, which causes this to change, this term, which inherently causes the whole term to change. But notice the B stays the same, the 2 stays the same. So again, looking at the different pieces of expression, what changes, what doesn't. All right, let's take a look at one more expression here. Now this is a great example because notice we're looking at a different expression. Now again, it didn't come out here to it, so I'll rewrite it. Okay, you deposit money in a bank and it earns interest on an initial amount as well as interest earned as time passes. Okay, so this is called compounded interest. And we have an equation for this. And this equation we're going to use quite a bit. It's exponential, which we'll refer to a lot in this class. And it says here what the pieces are. So I'll just kind of go through what they are. So we have P. This is how much money you put in. So this is your deposit. Okay, so if you got $1,000, you put $1,000 in a bank. Now, what do these pieces mean? Okay, well, if you put the money in the bank, you get 1 times that money. You put $1,000 in, 1,000 times 1 is $1,000. Now they're going to pay you money by keeping the money in the bank at a certain rate. So we put the rate right here. So this is the rate of interest. So make a note here. Okay, and the last thing is n. Now notice it's an exponent, and this is time. Okay, in this case. Now, since this one's it's perhaps compounded annually, which means every year you keep adding the same percent. So, for instance, if you put $1,000 in and it was paid out 2% interest, it'd be 1 plus 0.02, so it'd be 1.02, and then that would happen for every year you kept your money in there. So the first year you'd have $102, and then you'd take $102 and add 2% to it. So it exponentially gets bigger, bigger, and bigger. Now, what this is, we're going to see lots of examples of this. Let's first talk about the different pieces here. How does the change in each variable affect by the value of the expression? And we're looking at where P represents initial deposit, R represents interest rate, and N represents the number of month. So the things we want to look at is, let's first identify the pieces. We have one term. Notice the whole thing's a term. Now, a lot of people say, well, there's plus and minus signs, but that plus and minus is inside parentheses. Okay, so the whole thing is one term. The term is made up of a couple different pieces. We have a variable out here, which is a factor. And notice that factor is being multiplied by what? This entire thing is a factor. Okay, so here we have factor times factor, and that product is a term. Okay, now let's say it was 2%. I'm just going to say an example here. And let's say your P initially was $1,000. And then let's say it was going to keep it in there for 5 years. Okay. So putting labels on it so we know what we're talking about. If we change the amount of money we put in, let's say instead of $1,000, you put in $2,000 to start off with, does that affect other pieces of the equation? Well, it affects the P. because the P changes. But does it affect the 1? No. Does it affect the rate? No, the bank's not going to pay you a higher interest because you have more money. It's going to pay you the same interest. Now, more interest and more money means more interest, but the R itself doesn't change. You're still going to keep it in there for 5 years. You're going to have more money at the end, but the time doesn't change. So the only thing that changes in here is the P. Notice this factor in the big black box does not change. The only thing that changes is the P. Okay. Now, let's say it was back to $1,000. Let's say you went to a competitor bank and they were going to give you 3%. Well, the R changes, this factor changes, but does the P change? Do you show up with more money because of that? No, the money you have is the same. So notice these two factors work together to give you the overall price. But the two factors really have nothing to do with one another. One doesn't affect the other. The only thing that does change is the overall price of your account when it's done. So does your bank account, your final balance after 5 years change? Yes, it is. But that's because the product of change. Okay, so the P and then this factor are independent of each other. Now, the other thing that can change here is the N. Let's say instead of 5 years, you're going to keep it in there for 7 years. What changes? Again, this term changes because the 7 is inside this term. So the rate doesn't change, but it's being raised to a higher exponent. So this factor changes. Does your initial $1,000 change when you first put it in? No. It changes 7 years later, yes. Okay, so those are the different pieces that we have to look at. Okay, um, so this is a good video to refer to on identifying if one thing changes, how does it affect the other pieces.